Welcome back, students. In this video, we're going to cover lesson 8.2. This is angle similarity. Let's go ahead and get started. Let me adjust this light. There we go. Whoop. All right, angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Excuse me. So just like we were talking about in the previous lesson with dilations, if say we have the same angle, we just blow it up. Of course, I can't draw great, but if we blow up this triangle, the angles stay the same. The sides are in proportion to where they were. So that's why we say angle similarity. So the angles are going to be congruent, but the triangles are similar, and it's going to be because their sides are going to be in proportion. So let me stop getting ahead of myself and just read. So similar means that they are the same triangle but different sizes. We show two things are similar with this symbol. So it looks like the little tilde above the equal sign that shows us a congruent sign. It's just take away the equal sign and that means similar. So I'm saying down here, if A is congruent to Y, so A to Y and B to Z, so you have two angles, then you can say that ABC and YZX are similar, because they had two angles. All right, if triangles are similar, we can use proportions to solve the missing measurements. So over here in our example, BC is 24, and it's corresponding to EF, which is 16. AC is 21, and it's corresponding to DF, which is X. So we put these in proportion. We'll say, and if you start with the left, like let's say your top number's over here, on the left, your top number for the right better be over here. Bottom, yeah, it does. As long as you see 24 over 16, so we went from here to here, and then the same side, 21 over X. And then we do what you guys will remember as the butterfly method. So we're gonna cross multiply. So you got 24 times X, which is 24X, and then 21 times 16, which is excuse me, 336. Divide both sides by 24, and X equals 14 in that case. So that puts it in proportion with the other sides. Let's do a couple of practice here. I'm actually only going to do, you know what? I'll do the one in the middle. This is pretty easy. This is going to be similar to this. This is just practice solving proportions. So you cross multiply, so the butterfly method. And so over here, 6 and X make 6X. Here we're going to, and I'm going to write this out so that I can show you guys just a little refresher in algebra. So 6X comes down. So we have to distribute the 3. 3 times 3X is 9X. And then 3 times 2 is 6. All right, so now we'll solve. Subtract 6X, subtract 6X. We have 3X plus 6 equals 0. Another chance to show you guys. So minus 6 minus 6. 3X equals negative 6. Divide both sides by 3, and X equals negative 2. If I could have gone ahead and just moved the 9 over there, and it would have been negative 3 equals positive 6. You divide it out, and you still get negative 2. So over here, again, cross multiply over here, do the same thing. I'm going to flip over. All right, top of the page. Excuse me. All right. Determine whether triangles are similar. Explain your reasoning. All right, so here L is congruent to L. Well, L goes with both triangles, so that's why we say that. And anytime something is congruent to itself, it is always the reflexive property. And as I've told you guys, think about something being congruent to itself. If you look in the mirror, you're the same size. You're you in the mirror, so you're congruent to you, and it's your reflection. And this is reflexive. That's as close as I got for you. All right, so for this LPQ, so LPQ is, let's see, this angle, LPQ is congruent to LJK. LJK. K. Do this. Hold on. So, well, I meant to do 2. Oops, there we go. All right, and they're congruent to each other because of the corresponding angles theorem. So you see these two parallel lines, these keep going here. So this would be bottom left, and I know your guys are like, what are you talking about? So this line would go on forever here and here. So 1, 2, we've got angles here, 1, 2, 3, 4, 1, 2, 3, 4. These two guys are both in the same spot. They're both to the left of the parallel line and to the bottom of the transversal in this case. So corresponding angles. All right, now we can say that those two triangles are congruent to each other. Similar to each other. So let me get ahead of myself. Similar to each other. Because of the angle similarity. So angle and an angle. Angle and an angle. It goes with both. All right, let's scooch down. We're going to do, what I'll do is I'll do these two and I'm going to leave the one at the bottom for you guys. We'll do it that way. So determine whether the triangles are similar. Explain your reasoning. So it says by the angle triangle sum theorem, and so let me see, angle A is blank and angle G is blank. All right, so we have two triangles. Both of them have a box. We know the box means 90-degree angle. Thank you. Glad you knew that. All right, in this case, so one's 44 and one's 47 are two acute angles. So 90 minus 44 is 46. So that's going to be angle A, because all three of them equal 180. 180 minus our 90-degree angle means we just have to say 90 minus this. So angle A is 46 degrees. Then over here, 90 minus 47 is going to be 43. So that's angle G. All right, so angle A is 46, angle G is 43. And in this case, are they similar? No. Well, actually, it's asking about congruency, but that's okay. So, because two pairs of angles are not congruent, it should have said are or are not, but it's definitely not, and they are not similar. And it's because none of these angles, so the 90 goes together, but 44 doesn't match 43 or 47, and 46 doesn't match 43 or 47, so none of those angles are congruent. So we do not have similar triangles. Okay. Identify if the triangles are similar. If they are, we need the measure of AC. So I'm going to start out putting AC is over here as x plus 1. So once I solve for x, we just plug it in right here. All right, so we have two right triangles. And we have at least one of the acute angles are congruent. So yes, they're similar by angle. So yes, by angle. Oh, yeah, I didn't write that on the other page. Sorry. So now we need to solve for x. So we have, see where the 90-degree angle is. See where these, so we're going to say ABC, which makes D and DBE. So we'll say ABC. So triangle ABC is similar to triangle DBE. So this tells us what corresponds. A goes with D, of course B goes together. AB and DB, BC and BE. So DE should go with AC. So we'll go AC to DC and DE, not DC. Crazy. AC to DE. And then it's BC to BE. So we need corresponding. Remember, if we start with this triangle on top, it needs to be on top both ways. That's how we did that. So let's plug these in, cross multiply. Excuse me. So AC is x plus 1. DE is x plus 5. And BC is 12. And BE is 15. So we're going to butterfly like this and like this. All right, so let's start this way. So 15 times x is 15x, and then 1 times 15 is 15. 12 times x is 12x, and 12 times 5 is 60. So now we're going to solve from this point. So minus 12x, minus 12x. I'm going to move this over here. So 15x minus 12x is 3x, plus 15 equals 60. All right, now minus 15 minus 15. 3x equals 50. I'm sorry, 45, because that's 15. Yeah, oops, 45. 3x equals 45. Divide both sides by 3. So x equals 15. Now we need to plug that in up here because they wanted AC. So AC equals 15 plus 1, which is 16. Okay. All right, you're going to do the same thing with the bottom of the page. If you have any questions, let me know. Send me a message in Focus or Teams, or comment to the video if you're not in my class. Consider liking and subscribing, and until next time, I'll see you guys in the next video.